What is going on, team? It is your friend Austin here with AP Space, and today we are going to develop the GPIO software on a ATSAME70N21B-CNT. And to begin, we are going to review our schematic. So this is the ATSAM E70N21B, and this is what the schematic looks like. So here's our U2 power supply, our U3 power supply, connectors, another connector, resistors and decoupling capacitors, and other ICs. And what we really need today is to look at the J1 connector, and we're going to use the PD1 pin to configure our GPIO software. So we're using D1, effectively speaking, and what we need to do is open up MPLAB X IDE. And then we want to go to File, New Project, Microchip Embedded, Application Project, go Next. And then we want to go to 32-bit MCUs, pick 32C/SAM. We want to go to ATSAME70N21B. ATSAME70N21B. And then we want to use our AML ICE programmer. And then that's all set. So we go to next. We select our XC32 compiler V4.40, and then we go to next. We want to select our folder. So it's in the software folder, Photon 3v1, Photon 3v1 GPIO2, and then we can open that up. And then we're just going to call this the Photon 3 underscore v1, excuse me, v1 GPIO2, and then we'll finish that up to generate the project. And if MCC content manager wants to download anything, we can finish that up. And then our project will initialize. What we can view is the pin configurator. Then we can go to organize via ports. We can go to PD1, and then we can set that to GPIO. And now our pin D1 is set to GPIO, and direction, make sure that's set to out. And then that should be fine. So GPIO output, and then we need to go to our clock configurator, and this is where you can view our clock. So it's already set to 300 megahertz, and this can actually all remain the same. So we don't need to edit this. We are using our main RC oscillator set to 12 megahertz, and no edits are needed here. So we won't make edits. We have all that, And now we would like to generate the project. So you can go to project resources and go to generate. And then we can import other protocols in here. We don't need anything for the GPIO. So we now have our two projects, and to open up our main project, we go here, and this is what the blank project essentially makes. And to fast track this, we're just going to open up our other projects, and we're just going to copy and paste three blocks. Okay, so block one is just a variable, a counter variable set to 0. We copy that and then paste that in. We need our block 2, which is effectively just initializing our GPIO, which is the PIO initialize function. And we'll copy that whole block here and put that in the main under sys initialize. Here it's block 2 and block 3. We will copy and paste from block 3 where it's commented block 3, and we need this jazz here, and we put that right under system tasks. Put that all there. And effectively speaking, what did we import, right? So this is a counter variable, it's an integer. Enough said there. The PIO initialize function is actually in our resources, or excuse me, it's in classes, and then you can go to look up the function, and you see PIO initialize right here. So you can find the functions in the classes, and you can double click on here and it'll bring you to the function. Furthermore, you can actually highlight and you can go to the declaration / definition, and it'll bring you to the plib_pio.c function, and it'll show you exactly how the registers are being set. And if you're digging more into that, that's here. And that is pretty important to be able to navigate to functions and actually like read what the functions are doing. So that's just like one skill to have in MPLABX and IDEs in general. If you want to see what we're doing in block 3, which is where all of the real processing is happening, we are basically turning on the LED with PIO port set, and we're turning off the LED with PIO port clear. And what we want to show you guys here is the how you know what hardware we're or what pin we're using, right? So we have our schematic up already. We showed you guys the schematic. That's here, and we navigate to photon 3 V1 J1, and this is how the layout is, right? So PD1 is here and ground is here, and we have two wires plugged into PD1 and ground on our J1 connector on our photon 3 V1. Once more, this is the controller. We're plugged into these pins here to LED. And if you want to understand the function, what we can also do is go here and we can copy this, go to the internet, and copy and paste the function and just simply type microchip GPIO port set, and then we open up the microchip forums website, the online documents website, and the GPIO port set function effectively just selects what port you're using. So we're using port D, and it uses a unsigned integer with 32 bits as the mask. And the only thing you really need to know here is the description is this function sets to 1 the selected IO pins of a port. The example is what's really going to like tell you how to implement this. The GPIO port set is suggesting this sets RC5 and RC7 pins to 1, meaning that it'll just turn on an LED or it'll put the pin to high voltage if we set the bits to 1. And why is this setting RC5 and RC7 to 1? So this is something that I actually went through myself, and this is a hex number, right? So uh, 0x00A0 breaks down into binary. And if you go from hex to binary, this is the binary number. And what we're seeing here is that, and this is the example, right? So this correlates this bit, the least significant bit correlates to RC0, okay? So RC0, RC1, RC2, RC3, RC4, RC5 is 1, RC6 is 0, RC7 is 1. And A correlates to 1, 0, 1, 0. And that is why this example says GPIO port C and 0x00A0 effectively turns on 2 GPIO pins for the outputs. And similarly, the PIO port clear function does the same thing, except for when you set the bit to 1, it clears the pin basically. So you can also go here and then you can right click and you can navigate to declarations less definition, and it'll show you the function as well where that's located. So we have our delay loops as well. This is when I is less than 100,000, no operation I++, and then initialize it to 0 is approximately a second. And then we're setting the GPIO on, and then we're turning it off with this here. And what we would like to do is we can go to, okay, so that you can, this is already set as the main project, so we don't need to reset it as the main project. And we would like to build the main project. Loading completed. So build successful, no errors on that. And we would like to just simply run main project, and then it'll erase what's currently in the memory in the microcontroller. The LED is off right now, and then when it says programming complete, you'll have the LED blinking, and right now the LED is turning on and off. and we effectively set pin D1 to on and off. So it's off here, we delay, and then it's off, and then we delay. And then the reason why it's here is that we're using a hex number. And when we go back to our notepad, we see that if we want pin D1, remember it's not this bit position, because this is pin D0 in the least significant bit. Right next to it is pin, this highlighted bit is pin D1. So this is basically like introduction to bit masking. And if you want to be able to control the GPIO pins, this is how you do it. You basically tell the microcontroller the instruction that we want the GPIO port D, and then we're selecting pin D1. And this is how you select pin D1. You use hex 2 or hexadecimal, the number hexadecimal 2 and hexadecimal 2 to turn pin D1 on and off. And that's the implementation of the GPIO. So we have successfully programmed our board from start to finish in how we configure the GPIO on a ATSAM E70N21B. And you guys all have a wonderful day.